8.2, exponential decay. All right, so we have our function, our exponential function, a times b to the x. For our growth, that's what we talked about the last couple of days. With growth, a is greater than 0 and b is greater than 1. But for decay, and that's what we're focusing on today, a is greater than 0 still, but now b is between 0 and 1. It is a fraction. Decay will be fractions. So, without using a calculator and without plugging them in, if I just gave you two equations, would you be able to tell which ones are growth and which ones are decay? So here I have 1/3 times 1/2 to the negative x, and here I have 4 times 8/5 to the x. Now this a, what this really does is it tells me I'm above the x-axis or below the x-axis, just like it does in a parabola. I'm either above the x-axis or below the x-axis, but I can still be growth above and below, just like I can be decay above and below. So when this says greater than 0, it's just talking about a traditional. You can be below the axis and still be growth and decay. What's important is this information. Am I greater than 1? Or am I between 0 and 1? So if these are my two equations, I look at my b. 1/2, that's between 0 and 1, so this problem is a decay. Over here, I look at 8/5. 8/5 is a fraction, but it's a fraction that's bigger than 1, therefore this would end up being a growth. So please make sure that you're aware of the difference in the equations, because that would be a non-calculator question on a quiz, is being able to recognize your different equations. When you're graphing a decay, it has the same properties as a growth. That means the y-intercept is at a. It's the point 0a. The asymptote is k. And you shift all the same way. The h moves me left and right, the k moves me up and down. All right, so we're going to do a couple of these graphs. So let's graph by hand -2 and then 1/3 to the x. Again, by hand, you're going to use a t-table, -2, -1, 0, 1, and 2. When I plug in a -2, the negative is going to cross the line and change the sign, so that becomes -18. Plug in a -1, we get -6. Plug in a 0 is -2. Plug in a 1 is -2/3. And plug in a 2 is -2/9. Alright, when I plot these points, -2 to 2, -18 to -2/9. I don't need to have more than that. However, I do need to have labels, arrows, axes. 18 is larger than 15, so I can go by a different value. Maybe I go by 3s. 6, 9, 12, 15, 18. Negative 2, negative 1, 0, 1, and 2. Okay, so I connect my dots, and I make sure I go back and I put in my asymptote. The k is 0, so I need to make sure I have asymptote, make sure I have arrows, connect all the information. All right, y equals 4, 2/5 to the x. Take a second and try it on your own. Pause the video and then come back to it and see if what you have matches what I have. So pause it and try the example on your own. All right. You should have set up your t-table as negative 2, negative 1, 0, 1, and 2. When you plug in your x and y values, negative 2 would have given you 25, 10, 4, 8/5, and then put in the 2, which is 16/25. When I go to make my picture, I'm going to have large numbers, so I'm going to have y values up there. Got my x values. I got arrows. I got labels. I'm probably going to go by 5s. And then negative 2, 25. Negative 1, 10. 0, oops, negative 1, 10. 0's 4. 1 is going to be 8/5, and 2 is going to be 16/25. Connect our dots. And our k up here is 0, so I need to go back and make sure I put an asymptote at 0. Okay, so whether we're above the line, below the line, those are both still decays. So let's look at a shift. When it comes to shifting, we do these exactly the same way that we do the growth ones, meaning we first graph or do our t-table of a, bx. So we're only looking at 5, 1/8, and x. We'll worry about the 1 and the negative 2 later. So when I do my t-table here, I'm going to do 5 and 1/8, negative 2, negative 1, 0, 1, and 2. So when I plug in a negative 2 crosses the line, changes the sign. So I'm going to get a pretty large number of 320. Negative 1 gives me 40. 0 gives me a 5. 1 gives me 5/8. And then the 2 gives me 5 over 5/12. Right. 5 times 1/8 to the third, which is 5 times 1 over 8 to the third, which is 5 over 5/12. Oops, that was only 2. That's why it's not working out, because it's 2 plugging into 2, not plugging into 3. So that's 1 over 64, so 5 over 64. That's a better number. Okay, so now we need to shift When we shift, we're going to do 1 to the left because we're going to do the opposite sign. And then we're going to do 2 down. So that means subtract 2. 1 to the left means subtract 1. So a -2 becomes a -3, -2, -1, 0, and 1. Subtract 2 becomes 318, becomes 38, becomes 3, 5/8, subtract 2 is -11/8, and 5/64 subtract 2 is -123/64. Okay, plot these points. I'm going to go from -3 to 1 on my x-axis, and I'm going from a really big number on my y to just below asymptotes at 2 on my y-axis. So I'm going to make 1, 2, 3, and 1 arrows. 1, 2, because 2 is going to be my, but I don't want to go by ones. So if I have to go clear up to 318, 2 is actually going to be up here because I'm going to definitely use a different scale. Maybe my scale is going to go by 10s, 20s, 50s. If we went by 50, 100, 152, 253, 350, that means this would be -50, which means -2 is way down there, really close to the x-axis. And that's my asymptote. Might want to put that in just so that I know that I'm not going to go below that line. So I have -3 and way up at 318. So 100, 200, 300, somewhere around there. -2 is 38, so here. And we're getting really small. 1 is going to be 0 is at a negative, and 1 is at a negative. Connect our dots with arrows. And again, they're not exactly perfect. I mean 318, 320, 350, but I do have a good idea. I know that I went, as long as my scales and stuff are marked, it's going to be okay. So when we're doing our shifts, we always start -2 to 2, and then we do the shifts off to the side, and that's what we actually end up graphing. All right, the last part of exponential decay are the word problems. And the word problems are extremely similar to what we did yesterday with the growth problems. The only difference between them is the minus sign, which makes sense. Growth would be addition, so that's add. Decay would be subtraction, so it's negative. All right, but everything else is the same. So A is our final amount. P is our initial. R is our rate as a decimal. T is our time in years. And then N is how frequently per year it happens. We actually call the growth rate is that parenthesis part, 1 minus R over N. That's actually called the growth, or I'm sorry, decay. Decay, because we're working on decay today. That is actually the decay rate. So if you're ever asked what is the decay rate, it is 1 minus the R over N, or it just might be R because maybe the N is inconsequential. But there is exponential decay. It's very similar to growth. We'll go from there.